operations with plane vectors. So what's going on here, we're going to add and subtract vectors in a plane. So let's say I give you vector A, and I give vector B, and you want to add them. Well, if you remember when we talked about how to graph them by adding, you want to add tip to tail. So you added like a vector A and B like that, and then your answer would be the resultant from where you started to where you ended. A plus B. How does that work in component form? When you have points, you just add the points. Easiest thing in the world. So like, let's do an example real quick. We want us to add vector A with vector B. All we're going to do to get our vector A plus B is just add the corresponding ports. So you add the x value with the x value. So that'll be 5. 1 plus 4 is 5. And then you add the y value with the y value. Negative plus 7 is 4. And you get the point right there. 5, 4. Easiest thing, as easy as it could be. Let's check our answers graphically, which you generally don't have to do because it's so easy, but let's just to show you the visual. What's going on here. Again, it's not going to be perfect, but we'll try. So, that. Now let's graph A, 1 and negative 3. So something to this effect. That's my A. And then B will be 4, 7. So over 4 and up 7. So that's my B. Now if we're doing tip to tail, so all I'm going to do is basically slide this vector down here. So your vector's going to look like this. If I slide it down, it's going to start right here. And it's going to go basically over 4 and up 7. And then we will get the points. Something to that effect. Remember, the vector is the resultant from the origin, actually from when we started to there. That would be A plus B, which we look at it's about 5, 4. Again, not a perfect graph, but that gets you the general gist. Okay, how about we adding negative vectors? So first, what's a negative vector, right? So if you have vector A, it's 2/3, or 2 over 3. Its negative is just negative A. So you distribute, and you get negative 2 over negative 3. So right here, it shows you right, a normal 2, 3, you go over 2, up 3. Negative 2, 3, you go left, because left is negative for x's, and then down to negative for y. And next, what if we want to subtract vectors? Well, we talked about this before. There actually is no subtraction. You're just going to add the negative. So here, yeah, if you wanted A minus B, all we're going to do is go A plus negative B. Right, so when we did that by graphing, you went, okay, here's my A. B would be up here, but we draw the negative instead, so you go the opposite direction. So A plus negative B, and then your answer is from the origin to where you ended. From the start to where you ended, I should say. With numbers components, you just add and subtract like normal numbers. That's all. Just make sure, right? X plus X or X minus X, Y and Y. So for a quick review right here, a quick example, we'll do these. So they want Q minus P, so Q is 1 and 4, P is 3 and negative 2. First, do the corresponding parts. 1 minus 3 is negative 2. Essentially, we get this. And 4 minus negative 2, which will give me positive 2, 6. So you just add, subtract like normal. B, P is what? 3, negative 2. Minus Q, which is 1, 4. Oh no. Minus R, negative 2, negative 5. Alright, so again, just as long as you keep all the corresponding parts, you're going to be fine. So 3 minus 1 is 2. 2 minus negative 2, double negative, makes it a positive 2. So it's actually 4. Alright, I guess if I want, I can write it like this. 3 minus 1 minus negative 2. And then the bottom would be negative 2 minus 4 minus negative 5. Which would be positive 5. Right, so that's just positive 5. Negative 2 minus 4 is negative 6. Plus 5 is negative 1. Right. Adding subtracting vectors should be one of the easiest things there is. How about we multiply by a scalar? Remember, scalar is this fancy talk for a number. So what if we multiply a vector by a number? So if I, like here, I give you A. Well, if I want 2 A's, that's just 2 of the same A. So you just add 2 A's together or multiply each one by 2. Just like normal. Basically distribute. As I show you there. Right, so right here, if I want 3Q, you just do 3 times Q. Do to both of them, so you should get 6, negative 9. B, P plus 2Q. It's the last one I'm doing this one, because come on, we're not in first grade. So 2Q is 2 times negative 3. Again, distribute first to both. So I get 4 and negative 6. And I'm going to add 4, 1 to that. All you do is just add like terms. So I get 8 and -5. Okay, if I want to do this one, same idea. This 1/2 p minus 3q. Okay, last one. I want p minus 2q, but then I want this absolute value of it. Remember, in vectors, that means magnitude, which is a formula in your former sheet. Radical a squared plus b squared. We want the length of this vector. So first we got to find p minus 2q. So p is 3i minus 5j minus 2q, so 2 times q, which is -I minus 2j. If you notice, right, this is in the unit vector form. It's with i's and j's. If you want, you can write it like this. It's the exact same thing. I'll just do i's and j's for now because it's the way I was given. So you just distribute plus 2i plus 4j. It's kind of easier to add vectors this way. You just add corresponding parts. So I get 5i, that should have been a j, minus j. So that's what happens when I add these two vectors. I get this. Now I want the magnitude, so you just use the formula to figure out how long this vector is. Now when you plug them into here, into this formula, remember, don't plug in the I and j. This lets you know what's x and y. So this lets me know, oh, this is a, my b is -1. So you just unplug that in. So 5 squared plus -1 squared. So 25 plus 1, radical 26. And there you go.